So, could the most complex technology humanity has ever dreamed up actually be our secret weapon against climate change? We hear all the time about quantum computing breaking encryption or discovering new drugs. But today, we're looking at its role in something even bigger: the global energy transition. Let's dive into how this incredibly powerful new tech is actually being put to work.
And that's the big question, isn't it? Is this the one piece of tech that's going to swoop in and solve our energy and climate crises? I mean, it's a really compelling idea. But the reality? Well, the reality is a lot more nuanced, and frankly, a lot more interesting. And this quote right here, it just gets to the heart of it. We've got to shift our thinking away from some kind of magic wand and see it for what it is: a specialist tool. Think of it like a new, super powerful instrument being added to our climate fighting toolbox. It's designed for very specific, very, very difficult jobs.
Okay, so if it's not a miracle cure, what does it actually do? Well, right now, in the green tech world, quantum's work really boils down to two critical functions. And these aren't just theories, they're already being piloted around the globe. On one hand, you've got optimization. This is all about making our current systems smarter, more efficient. Think of it like trying to solve a massive, incredibly complex logistical puzzle. And on the other hand, you have simulation. This is totally different. This is about designing the future from the atom up, inventing the brand new materials we desperately need for a clean energy economy. So let's start with grid optimization. Our power grids are under some serious pressure, right? Especially as we keep adding renewables like wind and solar that don't run 24/7. Quantum algorithms are just perfect for these huge, what they call combinatorial problems. Imagine trying to find the single best route for 1 million delivery trucks all at the same time. A regular computer just gets bogged down checking every single option one by one. But a quantum computer, it can explore tons of possibilities simultaneously, making it ideal for figuring out how to balance loads, predict outages, and weave all these new energy sources into the grid without a hitch. Then you've got material science. This is a game changer. If we want to design better batteries, or more efficient hydrogen fuel cells, or some revolutionary new solar panel, we have to understand chemistry at the quantum level. For a classical computer, that's a nightmare. Simulating even a simple molecule is like trying to read every book in a library all at once. But quantum computers, they're built to speak that language natively. It allows us to simulate and discover materials that, honestly, just weren't even in the realm of possibility before. And again, this isn't just theory. This is happening as we speak. There's this quiet but incredibly intense global race going on, with nations actively piloting these quantum solutions to get a real strategic edge in the green economy. You know, what's really striking when you look at this is the consensus among the heavy hitters. The US, Germany, China, Japan, Canada, they aren't just picking one path. Nope, they're pursuing both. They're working on optimizing their grids and simulating new materials. They're basically placing bets on both sides of the quantum coin. Take the United States, for example. You can see this dual-track approach perfectly. You've got the Department of Energy backing these big grid pilots, while at the same time in the private sector, you have companies like IonQ teaming up with Hyundai to simulate the next generation of EV batteries. And it's a really similar story over in Europe. In Germany, the famous Fraunhofer Institutes are right at the forefront. They're using quantum to model these super complex, decentralized energy networks and are even digging into the physics of geothermal systems. But it's not just about grids and batteries. Quantum's influence is starting to ripple out into other really critical renewable sectors. And each one has its own unique challenges that just happen to be perfectly suited for a quantum approach. And what's so fascinating here is how tailored these applications are becoming. For hydropower, you've got Canada modeling water flow to squeeze out every last drop of efficiency. For wind, Denmark is simulating turbulence to figure out the absolute perfect placement for turbines. And for solar, Portugal is pioneering quantum-enhanced forecasting to predict energy output. Each country is using this incredible tool to solve its own unique energy puzzles. Okay, so far it all sounds incredibly promising, right? But we have to ground ourselves in reality here. There are some really significant roadblocks standing between the exciting pilots we see today and a full-scale quantum green revolution. And these roadblocks, they're all tangled together. The hardware itself, it just isn't powerful or reliable enough yet. That, of course, contributes to an uncertain return on investment that could be years, maybe decades away. Then you've got a massive talent shortage, not enough people who understand both quantum physics and energy engineering. And hey, even if you solve all that,
Trying to integrate this brand new tech with our ancient grids is a total nightmare. All of this is happening while geopolitical competition threatens the global collaboration we really need to solve these problems. So, when you add all those challenges up, the bottom line is pretty clear. We are firmly, and I mean firmly, in the experimental phase. We have some amazing proofs of concept, some really exciting simulations, but we are not yet at the stage of widespread, full-scale deployment in our critical energy systems. So, where does that leave us? Well, it brings us right back to our central theme. We have to move past all the hype about a miracle cure and embrace quantum computing for what it really is: an indispensable, specialist tool for the absolute hardest parts of the energy transition. And as we look around, we're seeing two main strategies for adopting this tool. You've got the powerhouses, like the US and China, who are building everything themselves, the whole shebang, from the quantum chips all the way to the green infrastructure. But then you've got other nations, like India and Portugal, taking a faster, more nimble cloud-first approach. They're using platforms from the major tech giants to run their experiments without having to build a single qubit themselves. And looking just a few years down the road, to 2026, we can expect quantum's role to become way more deeply embedded. It's going to become essential for managing grids with lots of renewables. It's going to be a key accelerator in the race for better EV batteries. And it's going to be absolutely fundamental to unlocking the chemistry we need for a real hydrogen economy. You know, this quote just perfectly captures the new reality. Quantum computing isn't a replacement for our existing tools. It is the specialized accelerator we bring in to solve the hardest problems, the ones that live at that chaotic, messy intersection of climate science and extreme complexity. And that leaves us with the final question. This isn't just a technological race anymore. It's a strategic one. As quantum solidifies its role as a critical tool for sustainability, the nations and the companies that master it, they won't just be leading in technology. They'll be shaping the future of our planet. And who wins that race? Well, that's still a very open question.